Hi everyone, this is the introductory video to the lecture Design of Train Track System, the Minimum Expenditure Problem for 2020 Open Research Forum. Before we begin the introduction, let me briefly introduce myself. My name is Wang and I'm from Nanjing, China. I'm a rising sophomore at Yale University and also I'm a math major student. Okay, so let's begin our introduction video. In the lecture, I will first state the problem of the train track system, and then I will provide the mathematical formation for the problem, which is the minimum expenditure problem. The idea of minimum expenditure may be new to most of the students, so I will introduce the concepts of graph theory, tree, and also spanning tree. I would then provide two really useful algorithms to solve the minimum expenditure problem. And finally, I will provide some great real-life applications to stress the significance of the minimum expenditure problem. So let's first think about the construction of the train track system. When we build the train track system, we need to connect all the cities on our list so that any two cities are connected to each other. Or in other words, for any two cities, there's a way to go from one city to the other. And at the same time, we want the total distance reaches the minimum because the longer the distance is, the more material the company who build the train tracks will need. And then the higher the cost will be. So generally speaking, we want to design a system of train tracks such that on one hand, any two cities are connected to each other, and on the other hand, the total distance reaches the minimum. On the right of the slides, there is a map in the United States, and there are four cities, New York City, New Haven, Springfield, and Albany, to help you to have a clear idea of this problem. So there are also six distances of the pairs of the cities as shown in the graph. So in this problem, in this specific case, the smallest distance is shown as the graph on the left, which is 225 miles. And so this problem is actually a minimum expenditure problem. So the graph we showed on the left was just a minimum expenditure. So this is the mathematical formation of this problem. And in this slides, I will show the problem in a mathematical way. And here we also notice that there are some really new terms for students, a spanning tree. So I will explain the basic concepts of graph, tree, and spanning tree for the students to have a better understanding of that. And then I will introduce two really useful algorithms. The first one is the Prim's algorithm. It is developed in 1930 by Czech mathematician, and then it was rediscovered and republished by the computer scientist Robert C. Prim in 1957 and also Dijkstra in 1959. And also another really useful algorithm is the Kruskal algorithm, which is written by Joseph Kruskal in 1956. So I will show how both the algorithms work firstly, and then if time permitted, I will try to prove the correctness of Prim's algorithm in the lecture. There are a great many real-life applications of the minimum expenditure problem. For example, the telecommunication networks, the water supply networks, and also computer networks. The problem was actually firstly invented when people consider about the construction of electrical grids, and this is also a great application of the problem. So this is how I will conduct my lecture, and thank you very much for listening my introductory video.